everybody, from the National Weather Service in Blacksburg. This is Phil Heisel alongside Dennis Slichter, one of our meteorologists. I'm going to turn the camera on just for a second so you can see us, and we appreciate both of you. Oh, let me get in the photo at least. Thank you so much, everybody, for joining tonight. So tonight's winter weather presentation, we're going to touch on the winter weather outlook. We're going to also talk about how you can share snow reports and where you can get weather information from our website. So for this interface, if you have any questions, because we have such a large number of people online, we cannot unmute folks to ask questions. I ask that you submit your questions in the question drop-down menu from this interface that you see shown here. Now, if you're on a PC, you should see this on your right-hand side. But if you're watching this from a tablet or a cell phone, you might have to scroll up from the bottom of your device to see this interface appear. And we will try to answer your question as quickly as possible. What we'll do is we'll wait between the slides to make sure we're not interrupting the presenter. So here's the outline for tonight's presentation. We'll start off with the seasonal outlook for this winter, talk about winter weather hazards that impact our area and how to prepare for these hazards, as well as how to find forecast information when there's an impending winter storm. Then we'll take a short break, and hydrologist Nick Fillo will join us then, and he'll present how to properly measure snow and how to get that important information to our office. So let's go ahead and start with the seasonal outlook that NOAA unveiled a couple of months ago. So for the period December through February this winter, the northern part of the United States, as well as the mid-Atlantic region, has higher than average chances of above normal temperatures. And the inset you see on the bottom left is specifically for Roanoke. And you can see that there's a 71% chance for normal or above normal temperatures this winter season. Now, this doesn't mean that we're not going to see snaps of cold air occur. Or if you may remember, last winter we had an above normal season in terms of temperatures, but we had that brutally cold period in the last week in December. So again, if you take the 3-month average, temperatures should be above normal, but there should be periodic bouts of colder than normal temperatures. In terms of precipitation, you see a pretty strong signal across the southeast and southern United States of above normal precipitation, with below normal precipitation this winter expected across the northern tier of the United States and into the Great Lakes. The inset you see on the bottom left is for Roanoke, and you can see there's a 70% chance that precipitation will be above normal for that 3-month period, and normal for Roanoke and for much of our area is about 9.5 inches. So what's driving this outlook is this El Nino. We're in a moderate El Nino right now, and it is expected to strengthen this winter season into a strong El Nino. And when you have an El Nino of that strength, that means these conditions are more likely to occur. And when you have a strong El Nino, typically what you see is those sea surface temperatures across the central Pacific being well above normal. And that really energizes that southern jet stream and allows for wetter and slightly cooler conditions across the south with above normal precipitation, which align really well with the outlook. Farther to the north, you'll see warmer and drier conditions, which again was reflected in that winter weather outlook. So I know a lot of people are asking, well, what does that mean for snow in our area? So this example looks at the past seasons where we were in a moderate El Nino in the late fall, early winter, and moved into a strong El Nino during the midwinter season. And the analogs that are most similar to what we're expecting this winter are the winters of 57-58, 65-66, 82-83, 97-98, and 2015 and 2016. And while this graphic is for Roanoke, all of the communities within our forecast area in southeast West Virginia, Western Virginia, and northwest North Carolina show similar results. And this shows that 4 of the 5 winter seasons had above normal snowfall. But it's interesting, you had the one season, 97-98, that was slightly below normal. So why is this the case? Because there are other oscillations besides the El Nino and La Nina that play a factor in whether or not the precipitation falls as rain or snow. Now, one of those oscillations is called the NAO, the North Atlantic Oscillation. And when that's in the negative phase, the winds aloft are weaker and it allows the cold air from Canada and the Arctic to spill down into the eastern United States. Oh, so by the way, Lucinda has a question. She says that she cannot see anything. Is anybody else having trouble seeing our images? All right, I don't see any comments in the questions. But if anybody else cannot see, all good. Thank you, Rory. So Lucinda, that may be a problem on your end because others can see Yeah, everybody else now is commenting that they can see it. Thank you so much, everybody, for your comments. So I'm sorry, listening to that, you're unable to see the images, but it may be again, an issue on your end because others are able to see it. So this North Atlantic oscillation, when it is in the positive mode, temperatures are warmer. Oh, okay, listen, I'm glad you can see our images now. And the positive mode of the North Atlantic oscillation typically means warmer temperatures, which allows the precipitation mainly to fall as rain. So that's really key. In this oscillation, unlike El Nino and La Nina that can be predicted months in advance, the North Atlantic oscillation can only be predicted a couple of weeks in advance. So that's going to play a really important role whether or not the precipitation that we see this winter falls as liquid or frozen. There was a study that was done that looked at winter seasons that had strong El Ninos and combined negative and positive North Atlantic oscillations. And they looked at this for several locations, including Roanoke. And I find it very interesting that when you have a strong El Nino and you combine that with a negative North Atlantic oscillation, look at the average snowfall, 39 inches in a winter season on average. That's double the normal value. And even with a positive North Atlantic oscillation, when you have a strong El Nino, those values are about normal. I think we can say with high confidence that we will see more snow than we saw last winter, and that's a pretty easy forecast. Now to talk about our headlines, I'm going to turn it over to Dennis Lichter. Dennis?
Hey, thanks, Phil. Phil was talking about snowfall amounts. Well, when we get so much snow, we want to let folks know about that in advance, and we have different ways we can do that. Taking a look across your screen from left to right, we have different types of products that we will issue for increased confidence and impact to life and property. We have the watch, which is we're letting you know 24 to 48 hours in advance that there's going to be some type of winter weather impacting your area. An advisory, we're looking in the 12 to 24-hour time period for the potential for minor impacts to roadways, so forth. You may want to consider leaving earlier or later if you need to for slick conditions. Now, the warning is when we are the most confident with the greatest impact across the area, with events happening within the 12 to 24-hour time period for impacts that will close roadways, extensive power outages, and other threats to life and property. For our particular area, we will issue winter storm watches when we are about 50% probability or greater, thinking that it will actually take place in the next 24 to 48 hours. This is the time period when you should be preparing for winter weather. For a winter weather advisory for roughly 2 to 3 inches of snow or less than a quarter inch of ice, that's what we will issue the advisories for. And these are usually up to 24 hours in advance, 36 hours if you have a lot of confidence. But if caution is exercised, it should not be life-threatening. Now, the winter storm warning, now we're looking in the range of 4 to 5 inches of snow or a quarter inch of ice or more, with about 80% greater confidence across the area. And this is issued up to 24 hours in advance, or again, 36 if confidence is really high. And during one of these events, we're encouraging to stay indoors and avoid travel if possible. Now, we do have some other types of warnings that we'll issue, but these are for very specialized events happening. These would be the blizzard warning and the ice storm warning. The blizzard warning, we're looking for a combination of wind and snow and blowing snow. We're looking for 35-mile-per-hour wind gusts or more, considerable blowing and drifting of snow, and that's blowing and drifting in snow is reducing visibility to less than 1/4 of a mile. With the ice storm warning, this is issued in lieu of a winter storm warning if the precipitation is all ice. There is no ice storm watch, though, and we're looking for a quarter of an inch of ice or more in 12 hours. And it's issued up to 24 hours in advance.
Dennis, somebody said they're having trouble hearing the audio, and I just want to make sure others are not experiencing that issue. All right, if anybody else is having trouble with the audio, please let us know. Otherwise, we'll proceed with the presentation.
Okay, thanks, Phil.
Oh, looks like everybody else says it's okay. Thanks, everybody, for the response.
Yeah, thank you. All right, continuing on. Another specialized high-impact winter weather product is the snow squall warning. Here, we're looking for sudden whiteout conditions with near zero visibility with heavy blowing snow. Also, during one of these events, sometimes we'll have what's called a flash freeze on the road, where precipitation, because of how the strong magnitude of the cold air arriving on the wet surfaces will freeze very quickly. And the magnitude and the intensity of this system coming through is very comparable to that of a severe thunderstorm warning coming through the particular area. It's very what we call convective in nature. And these are issued before the onset of the event, typically in the 30 to 60 minute time period ahead of the arrival of the snow squall. When we look at the impact-based warning tags, if you're familiar with those at the bottom of some of our products, you'll have either a general tag or significant, and also either observed or radar indicated, the means by which we know that this is occurring. And the general refers to what's used when it's used frequently for snow squall conditions, but mitigations actions combined with social context. In other words, what are the impacts in a broader sense across the area? Now, for significant, it's used only when snow squalls pose a substantial threat to safe travel, such that a WEA is warranted to alert all devices for a path. And we'll look at some more of those later. So let's take a look at what the winter weather criteria is across the area for different events. And these are highlighted by different colors here. The eastern part of our forecast area, we're looking at the 3 to 4 inch range, and then closer to 5 for the western half. So other parts of the country, you might be in that area, maybe on vacation, and you hear of a warning or watch. It's important to know what the criteria is for a particular location to know what the impact would be. So we took a look earlier at the snow squall with the WEA, the activation schedule. This is a whole list for when these would be issued. I won't read through all of them, but the ones most prudent for this particular time frame would be the snow squall warning for the winter activation.
Yeah, and that's a good point, Dennis, because there's been a change recently where not all snow squall warnings will trigger wireless emergency alerts. As you mentioned, just those with that significant tag. And for those who aren't familiar with wireless emergency alerts, those are the 90-character messages that you get on your cell phone that you don't have to sign up for when you buy a new cell phone and turn it on. These are the warnings that will trigger that. And notice there are numerous warnings that do not trigger wireless emergency alerts. A large majority of the severe thunderstorm warnings don't trigger wireless emergency alerts. Most of the flash flood warnings don't. Winter storm warnings do not trigger wireless emergency alerts. So if you'd like to receive notifications for these other warnings, we encourage you to go to weather.gov/subscribe to find other ways to get that information alerted to you.
Okay, thank you, Phil. So when we talk about winter weather hazards, what are these main hazards? Well, primarily, we're looking at snow and sleet, freezing rain, blizzards, snow squalls, and cold temperatures. Let's first talk about snow and sleet. Snow and sleet primarily affect travel, but can also damage infrastructure. And damage from winter storms sometimes can exceed $1 billion annually. And the National Weather Service will issue winter storm warnings or winter storm advisories as appropriate for the magnitude of snow that is expected. Now, when we're looking at freezing rain or ice, this can have a big impact on travel and can knock out power. Just take a look at the ice accumulation there on those power lines. We do encourage you to have an emergency kit in case the power does go out at your home. And the National Weather Service will issue ice storm warnings or winter weather advisories for the ice as the conditions warrant. So we compare ice storms and blizzards. We're looking primarily at ice storms being winter storms where damaging accumulations are expected. Heavy accumulations of ice can bring down trees and topple utility poles and communication towers. And if you think about it, even small accumulations of ice can be extremely dangerous to motorists and pedestrians. But ice storm warnings are issued when we expect at least 1/4 inch of ice. Now, sometimes you have a fine film of ice on the ground, which is also very significant in terms of potentially needing a winter weather advisory. But ice storm watches are not products, and they will never be issued. Looking at the blizzard, though, blizzard impacts, again, places. Let's see, got a message here, I think.
Yeah, Barry says the audio went out. So again, we'll ask folks if they're having any issues with the audio. Oh, okay, Stephanie, everybody else says okay. So I'm sorry, Dennis, go ahead and proceed. Thank you.
All right, thank you so much. Yeah, blizzards are winter storms that can produce several inches of snow, occurring with strong winds that cause blowing snow and whiteout conditions. And the blizzard warnings are issued when we're looking for that combination of wind gusts of 35 miles per hour or greater, and it reduces the visibility to 1/4 mile or less, sustaining for 3 hours or more. So we do also issue cold temperature products. These include the wind chill warning and the wind chill advisory. Both are the impact of wind speed increasing to such a degree that it causes the relative feel of the air around your body to be lower than the actual air temperature. And cold weather, again, this can cause frostbite. We encourage you to dress in layers to cover exposed skin and limit time outside. Now, the two differences between the wind chill advisory and the wind chill warning are the magnitude of that value. Now, eastern parts of our area will issue wind chill advisories for wind chills of 0 to 14 below 0. And across our mountain region, wind chills of 5 below 0 to 19 below 0. For those warnings, which are more significant and can cause frostbite in a shorter period of time, we're looking at 15 degrees or lower, minus 15 degrees or lower in the east, with wind speeds of 5 miles per hour or greater. And across our mountain region, we're looking for wind chills of minus 20 degrees Fahrenheit or lower. So what are some signs of hypothermia? Perhaps you're outside and working or playing in the snow. You're starting to experience some confusion, shivering, difficulty speaking, some sleepiness, and some stiff muscles. They can be signs of hypothermia starting to kick in, and definitely encourage you to seek shelter in a warmer location. I think we have a number here.
Yeah, question? Dennis, there's a question from Carrie. She says, that's a really good question. Why the differences between the numbers in the east versus the west for the wind chill warnings and advisories?
Well, all of our forecast offices have done a study in terms of assessing, speaking with community leaders, emergency managers, folks with authority of experience of how different wind chills have impacted people in their regions. And the farther south you go, people are less prepared for lower temperatures, lower wind chills. So they may not be as prompt to take action for lower wind chills. So it doesn't take as low of values to be of a significance to different areas based upon the impact that it has on that location. And across our area, we have found, the research shows that the values in the east don't have to be as low as those in the west for that impact to be noted by folks.
Yeah, great answer, Dennis. And I think part of it also, as you alluded to, is just the climatology, the frequency of occurrence. And people, obviously farther north, are more acclimated to those very cold temperatures.
Thank you for that question. So some tips for dressing for the cold weather. Looking from left to right on the screen, we have different individuals dressing for different conditions. We have, this is all, of course, relative, what chilly is and cold is and extreme is. But for chilly, we're looking for dressing in a couple of layers, longer layers too, potentially waterproof shoes. And once you get to the cold, we're looking for having a hat, 2 to 3 layers, perhaps 1 to 2 layers of pants, and definitely some waterproof boots. When we get into the extreme, 3 or more layers of tops, 2 layers of pants, a face mask, a hat, a very heavy coat, and very sturdy boots. So keep your information knowledgeable on what's happening on the outside, so you know the appropriate way to dress for particular conditions. And one way to do that is to check the forecast at our webpage, which is www.weather.gov/RNK. And you should try to plan accordingly based upon the expected weather conditions with the forecast. And if you must travel, make sure you have a winter survival kit in your car. And like the other slide was showing, dress appropriately for the conditions if you must go outside. And what constitutes that kit? For your home, we're looking for a kit that has food, water, medication, flashlight, extra batteries, and a first aid kit. Definitely have a plan if the power goes out. Know where your shelters are if you need shelters in your area. You should pay attention to your local news for updated information on the road conditions across your area. Definitely check with your local water company to ensure water is safe to drink. You may need to boil water potentially if there's a problem, because that sometimes can be an issue with water that is having issues. Also, check with utility companies to find out when electricity or gas service may be restored to your area. So if you need an emergency kit for your car, we're looking at things like a cell phone charger, first aid kit, jumper cables, spare tire, flares, extra fuel, kitty litter for traction, a tow rope, blankets, snow shovel, flashlight, extra mittens, hats, and boots, and some water and some snacks. So you definitely need to check your forecast and have multiple ways of getting that forecast. One way we definitely recommend is NOAA Weather Radio. That is a radio broadcast directly from our office. That is a continuous repeating forecast and weather conditions for your particular area. Also, you want to watch your local TV and listen to your local radio stations for the latest information as well. Also, if there were any wireless alerts that you received on your cell phone, you'll want to take heed those appropriately. Also, perhaps your area has outdoor sirens for some aspect of winter weather. Look at different websites, including weather.gov, and perhaps you'll get some information from your friends or family. They may want to call you and tell you what's going on in their area. I think we have another message.
Yeah, John mentions that AEP has an online map of outages. So yeah, that goes to the point you brought up earlier, Dennis.
Absolutely.
Yeah, it's a good resource. And always remember, Dennis, if it's weather you love, go to
weather.gov.
Yeah.
So we've been talking about outside winter safety. Did you know there's also indoor weather safety? Most importantly is the carbon monoxide detector. If you do not have one in your home, you should have one just like you would have potentially for a smoke detector. Carbon monoxide detector will detect carbon monoxide buildup in your home. It's definitely carbon dioxide is a poisonous gas. You cannot smell it, so it's definitely something you need to have a detector for if in fact it's happening in your home, and you'll get this potentially from malfunctioning gas heaters, gas fireplaces. So you definitely want to be alert if that is taking place in your home. So going back to outside, if you're caught outside in the storm, what should you do? First, definitely, just like for a thunderstorm, you should find shelter. If there is no shelter, you may need to build a lean-to or snow cave for protection. Try to build a fire for heat if possible. Cover exposed body parts and try to stay dry. This will help protect against hypothermia. Melt snow for drinking water. Avoid eating unmelted snow, which can lower your body temperature to deadly levels. And try to exercise occasionally. Move your fingers, your arms, toes. Try to keep warm by moving and staying active. So if you do have to drive during a storm, please take the following precautions. Try to slow down. More than 5,000 fatalities occur on the roadways each year due to wintry conditions. Before you drive your car, take time to ensure that your exhaust pipe is clear. That would be a concern again for the carbon monoxide buildup. Also, brush all snow off the car. This way it doesn't fall onto your windshield while you're driving or fly onto other cars causing an accident. Also, leave extra time for blocked, closed, or icy roads. Perhaps the typical way you travel from point A to point B is not possible because of the snow. Allow extra time to reach your destination because you're also going to be traveling more slowly. Now, if you are driving and begin to skid, remain calm, ease your foot off the gas, and turn your wheels in the direction you want the front of the car to go. If you have anti-lock brake, apply steady pressure to the brake pedal and never pump the brakes on an ABS-equipped vehicle. Now, if you're having trouble seeing due to weather conditions, pull over to the side of the road and stop your car until visibility improves. You also want to turn on your hazard lights. Now, if your vehicle unfortunately does get stuck in the snow during a storm, stay in your vehicle. If you leave your vehicle, you could become disoriented from the wind-driven snow and get lost in the blowing snow, and that is not something you want. Run your car motor about 10 minutes each hour for heat. Now, while running the motor, open the window a little bit for fresh air to avoid carbon dioxide poisoning, and that follows into the next point there. If possible, clear the snow from your exhaust tailpipe to avoid gas poisoning. Try to be visible to rescuers. If it's nighttime, turn on the dome light when you're running the engine. If you have one, please tie a bright colored cloth, preferably red, to your antenna or door. And after the snow stops falling, just like you might do for another emergency along the roadway, raise your hood to indicate that you need help. So where can you find weather information? Well, I'm going to show you one place on our webpage, but before we go there, I would like to welcome you to go to the handouts section of the menu. You'll see two handouts there listed under the drop-down of handouts. One is a National Weather Service Blacksburg Winter Weather Products form, and the other is a snow form. Right now, we're going to be discussing the one that is the winter weather products. So I'll be discussing some, but if you want to download that winter weather products download, the PDF, you'll find on there not only what we're talking about tonight, but additional information that you might find useful. So I will pause for just a couple of seconds for those that wish to download this form right now, but I will be moving on pretty quickly here. Okay, what's on the screen here is a snapshot of the bottom of the www.weather.gov/RNK main webpage. Now at the bottom, there'll be a number of icons that refer to different types of weather or other aspects of meteorology. What we're looking at tonight, though, is winter weather. So when we click on the winter weather icon, what can we find there? Well, snow forecast, probabilistic snow forecast. Essentially what we're looking at here, now this is not an image that's current. This is an old image, so this is not a current forecast. But what we're looking at is, on the left-hand side, is our expected snowfall. If you were to go to our forecast and read what our forecast is for wind, temperature, and so forth, you will find a snow forecast that maps the amount displayed on that map for that particular area. We're looking at western Greenbrier County in West Virginia, showing a small amount of snow. On the right-hand side, we have two smaller pictures. One is the high-end amount of snow, and one is the low-end amount of snow. Looking at the upper right-hand picture, that essentially is saying we are expecting it to snow, and if it snows, this is what we think it can get up to, which is going to be a value probably higher than the actual forecast. Excuse me. It'll be the forecast that you should try to plan for. The bottom right-hand corner is showing we expect at least this amount of snow to occur. So one range is at least as much, and the other range is up to this amount, with the left-hand picture being the general forecast.
Yeah, and so I could just add,
Sure,
this
Phil.
is really, I think, a really important tool to use because it shows the range of possibilities as you described, looking at 46 different weather models. And the larger the spread between the high end and low end amount, the lower the confidence is in the forecast. When those values are closer together, that means we have a higher confidence in that official forecast. So it also conveys confidence, I think.
Absolutely, yeah. So this is just another look at that picture, kind of what Phil was saying there. We have our official forecast in red. We have the reasonable worst case scenario there in the upper right. And in the bottom right is we expect at least this amount of snow to fall. Another item you can find on this page is the probability of snowfall exceeding or reaching a certain amount. And these are incremented in ranges of greater than or equal to 1/10 of an inch of snow, greater or equal to 1 inch of snow, 2 inches, 4 inches, 6 inches, 8 inches, 12 inches, and 18 inches. So you'll see colored contours. The larger map is showing the percentage of 1/10 of an inch of snow or more. And just looking at the colored bar, the vertical bar there ranging from white to a dark blue, the Western Greenbrier County forecast at that point in time was somewhere around the 30 to 40% chance of receiving 1/10 of an inch of snow or more. These maps are even more revealing when a greater amount of snow is forecast across the area. You can see all of those different thumbnails, the 1 inch, the 2 inch, the 4 inch, 6 inch, and so forth, all with their various ranges of probability. And all you need to do is take your mouse and cursor over each of those to display them in the larger screen. And a final table we can see, is a table actually, is looking at different locations along the rows from top to bottom in different places in West Virginia. There again is that range, the low end expected, the expected, and the high end range. Again, looking at that same, this is all generated from those same images we saw, but just in a tabular form. So let's just pick a location here. Let's pick Bluefield, West Virginia. The probability of receiving 0 is 30%. So it's less than the probability of receiving 1/10 to 1 inch of snow. So there's a better chance of receiving a small amount of snow than receiving no snow. So that figure there may be of a use to a highway department. We're letting them know that there's more chance of snow occurring on surfaces than not. But then as you continue to the right on that table, those numbers drop off pretty quickly. There's only about a 4% chance of receiving 1 to 2 inches of snow, and then 0% from 2 inches and higher. So perhaps someone that is involved in highway department, or perhaps whoever is contracting your business to do snow removal, they will know that there is a better chance of receiving some small amount of snow than receiving no snow, and there's no chance of receiving a large amount of snow. So these numbers can be used by different folks in different ways. Now let's say we have a storm that's approaching. Is there some way you can get a general feel for what the significant impacts will be of that storm? Well, there's a product that's called the Winter Storm Severity Index. And it is derived by looking at 6 types of categories, that being the snow amount, the snow load, the ice accumulation, flash freeze potential, blowing snow potential, and ground blizzard potential. So we have forecast values and what are called forecast grids that compose our forecast database. And this product makes use of those grids and other aspects to come up with these impacts of the severity. And looking on the right-hand side of the screen, we have a vertically based table showing different colors, ranging from a light blue to a dark purple. And they're taking a look at Western Michigan and the typical downstream lake effect of Lake Erie in Ontario. We're seeing colors in the yellow and the orange and a few spots in the red. So each of those are different types of impacts, with the higher amounts of impacts heading down that table. So an area in red, the major impacts, can expect worse conditions than those areas in yellow, which are minor impacts.
Yeah, real quick, Dennis. This is one of my favorite products that the Weather Service produces because, you mentioned the winter storm warnings we issue for like 4 or 5 inches of snow or more, the advisories for 2 to 4 inches. But, we find that in terms of impacts to transportation and injuries, I've seen, and I'm sure you have too, many cases where we have more injuries and even fatalities in those situations where we have just like 1 to 2 inches of snow, which are below advisory criteria. But then the cold air comes in behind it. We see that precipitation freeze on roadways, and there may not be a lot of lead time for those headlines versus the big winter storm that's going to produce 14 inches of snow. We'll have the headlines out 2 or 3 days in advance, and everybody takes the precautions. So I would, this is one go-to product I would look at before traveling. And there's a great question from Sharon. She asked I missed how he got to this winter storm severity index. That is all from our winter weather website. Remember, if it's weather you love, go to weather.gov and then just drill down, use the map, and click on Western Virginia. So it's weather.gov/RNK, and you'll see an icon at the bottom of a snowflake that says winter weather, and you'll find it there.
Thank you, Phil. Yeah, that's a good point. If you tell folks expect 1 to 2 feet of snow, everyone knows what to do with that. They know, okay, this is going to be a very significant, dangerous situation. But 1 inch of snow can be a significant situation if people are not expecting that snow to quickly freeze on roads, perhaps. So that's a really good point. So we were taking a look at snow. We also do this for ice accumulations. Of course, this map is blank, but you will find ice accumulation forecasts on this part of our web page as well. So now we've reached the time where I know we've been asking some questions, some of you throughout this part of the presentation, but now is a time to ask additional questions if you have some.
Okay, it's 7:15. I'm going to turn the camera on just real quick so you can see Nick Filler, our hydrologist, who's going to take you through the rest of the way. There's Nick.
Hey, everyone. How are you?
All right, so Nick's going to finish up the presentation and talk a little bit about how to measure snow and how to report it to us. All yours, Nick.
Thank you. So this is the part of the presentation that becomes a little bit more of the two-way street of information exchange. Because when we have a winter storm that's moving across our area, thank you, we have our weather radar that kind of gives us an idea where the precipitation's falling. We have our weather sensors kind of scattered across the region that let us know how much precipitation is falling here and there. But we all know that winter weather accumulations, snowfall accumulations, icing, things of that nature can change drastically over short distances. And this is where we kind of ask your help in sending in your winter weather reports to us so that we can keep our forecasts and we can keep our watches, warnings, and advisories accurate and up to date and tell people where the real threats are actually occurring. So in order to do that, we're going to start off by kind of taking a look at some of the definitions of the types of wintry precipitation that we might see this winter. And it ranges anywhere from snow to sleet to freezing rain and, even rainfall. And we all know what snow is. And it's that nice white fluffy stuff that we just love pushing around with shovels and brushing off our cars in the morning. And that starts off as a snowflake in the clouds, and pretty much from the time it's in the clouds all the way down to the ground, the temperature is below freezing. So it stays as a snowflake. Now, when it comes to sleet, sleet might start off as a snowflake, but there's some warm air up in the atmosphere that allows it to melt into a raindrop, but then that raindrop refreezes before it reaches the ground, and therefore it hits the ground as a frozen pellet. Now, both snow and sleet fall and hit the ground as frozen precipitation, and that's relevant, and we'll get into that a little bit more later on in the next few slides. But when it comes to freezing rain, freezing rain is rain that falls as liquid and only freezes after it reaches the surface. That's why it has that nice, smooth, glassy feel to it, complete oftentimes with icicles dangling off of trees and railings and things like that. All right. So now that we have that kind of outlined, we can get into how to actually measure some of the wintry precipitation. And the tools that you'll need for it are probably already lying around your house in some form or fashion. You'll need three things generally. You'll need a measuring stick, you'll need a snowboard, and a snow stake, which is just basically some form of marker to help you find the snowboard once it's covered with snow. So starting off with a snowboard. A snowboard can be any piece of plywood that you have lying around in the basement or in the garage. You may want it to be nice and sturdy, because we all know that sometimes when the wind picks up, we can get some really strong wind gusts across our area, sometimes 40, 50 miles per hour. And we don't want our snowboards to float away. So picking up, using a piece of wood that has some weight to it is preferable. It can be something that's anywhere from 2 feet by 2 feet in diameter, in area. And usually we want it painted white. And why is that? Because white objects, things that are painted white, they're poor absorbers of heat. And that allows the snow to stick around longer so that we can get a more accurate measurement. And one of the best things about a snowboard, it gives you a nice solid surface to measure the snowfall from. And here's a good example why. So measuring from our snowboard there, we see we can drive the ruler all the way down through the snow, touching the snowboard, and we got a measurement of a little over 3 inches. But when we measure from grassy surfaces, there runs the risk of pushing the ruler all the way down through the bottom of the snow and actually into the dirt, giving us an artificially high snowfall measurement. So measuring it from a solid surface is better. Measuring from a soft surface, such as measuring it from the grass. Okay. You want to use a ruler that's got tick marks in there so that you can measure to increments of an inch. And ideally, we want to choose a ruler or a yardstick that measures to tenths of an inch. We know that there aren't too many of those around. A lot of those rulers have measurements to 1/16 of an inch. That's still perfectly acceptable. What we would say is choose something that is solid, like made of metal or made of wood. Measuring tapes are kind of flimsy. I know they're convenient to use, but they're kind of flimsy and they may not penetrate all the way through the bottom of the snow, again, giving us an artificially low or artificially high snowfall measurement. So using something that's solid, made of wood or metal, is preferable. Uh-oh. What did I do here? Okay, so next thing we want to talk about is where to measure our snow and sleet. We want to choose somewhere that's out in the open, usually flat terrain. We want to avoid areas that can lead to an increased risk of drifting, such as buildings or fence lines or tree lines or things of that nature, where we might see drifting that causes artificially high or artificially low measurements. We also want to avoid near sidewalks and roadsides where people can shovel that snow off that roadside or walkway and pile it onto the grass there, again, giving us artificially high measurements simply because we're measuring a snow pile as opposed to undisturbed snowfall. There we go. Now, in this example here, we want to choose some place that's out in the open, and here's a good example why. Where this gentleman here in the left image is measuring, he's decided to choose right underneath a tree. And you can see in the picture there that the branches of the tree are snow covered. So a lot of the snow was caught up into the tree branches, and where he measured, he only had 3 inches on the ground. All he had to do was move over about 10 or 12 feet away to the more open area. And you can see here where the snow was allowed to fall straight to the ground without being caught up in anything. He had more than double the amount of measurement there, 6.5 inches. So a good example of why you want to choose an area that's out in the open to measure your snowfall. Now, measuring snowfall is very simple. Once you've located your snowboard, you simply take your ruler, you stick it straight down in the snow, preferably facing you so that you can see the tick marks on the ruler to give you an idea to what fraction of an inch, the closest fraction of an inch that your snowfall accumulation has made it to. And sometimes that means, squatting down a little bit so that you can get a better view of the tick marks, because you know how they are. They're very close together. They're sometimes difficult to see from a distance. So you want to get as close as you can to the ruler so that you can get a more accurate measurement of what snowfall has occurred in your area.
Yeah, we just got a question come in, Nick, from Robert, who asks, should the snowboard be on the ground or can it be elevated to eliminate drifting?
If you are in a flat area that you know that you don't typically see drifting, it's perfectly fine to leave it on the ground. And we're going to talk about that here in a second as to why having it on the ground is sometimes better than having it on an elevated surface. Here we go. So once you have measured your snowfall, the best thing to do, pick up your snowboard, you wipe it completely clear of snow. Wipe it completely clean and place it back on top of the snow in a different location from where you measured. So you don't want to take the board and put it back in the same hole that it came from just a moment ago. And here's why. By putting the snowboard, once it's cleaned, on top of the snow in a different location, you can now differentiate the new snow that falls later on from the old stuff that's already been on the ground. All right. By putting it back in the same hole that it was before, you run the risk of wind gusts coming along later on and blowing snow from the sides of the hole onto the board. And then it becomes very confusing to tell what's new snowfall and what's the same stuff that's been there. It just got blown around by the wind. So again, pick up your snowboard, clean it off, put it on top of the snow in a different location, and be sure to move your snow stakes with you so that you can easily find your board later on when it's time to take the next measurement. Now, as far as how frequently to measure, we ask that you measure no more than once every 6 hours. And the reason why is that if you take measurements more frequently than 6 hours, you might actually cause overinflated snowfall accumulations. We've had some reports from people that measured once an hour during heavy snowfall. And while we really appreciate that enthusiasm and that help from folks, we've seen that their snowfall measurements are several inches higher than everyone else's that's surrounding them in the nearby area. So again, once every 6 hours, to take a snowfall measurement. And the only exception to that rule, well, there's two actually. The first exception to that rule is take a measurement right when the snowfall ends. So if it's been snowing very heavy and then you see the snow has moved out of the area, go ahead and take a measurement, even if it's been within 6 hours, to get that final measurement of snow in. The only other exception is to do so only if you feel it's safe to go outside, because in some storms it's very icy, it's very windy, it's very cold. We don't want anyone to put themselves in danger by going out and slipping on the ice and hurting themselves, or being outside when it's exceptionally cold and they run into problems due to that. So please, if you feel it's too dangerous to be outside, please stay inside. We value your health a lot more than we value your snowfall measurement. All right. So we talked about settling of snow, and here's a couple of the things that can cause snowfall to settle, which is why we ask right at when snowfall ends to take that final measurement. We around here, the ground doesn't get very cold in the wintertime, so you actually have warm ground, warmth radiating upward that can cause snow to melt from underneath. When the sun comes out, even when the temperature is below freezing outside, when the sun comes out, it does cause those snow crystals, those snowflakes, to begin to contract and to settle. Weight of newer snow on top of older snow, winds, they all cause snowfall to settle and compact over time, which is why it's best to get that measurement right when the snowfall ends to get the most accurate measurement of how much snow has occurred. So this is a lot to absorb here. I'm going to go through this a little bit slowly, but this is taking measurements during our sample winter storm. And we woke up, saw it was snowing. We decided to take our first measurement at 9 o'clock in the morning. So here we are on the left image. I measured 2.4 inches of snow on my snowboard. And I picked it up, wiped it completely clean, put my snowboard on top of the snow in a slightly different area, and went to work. And came home at 4 o'clock, took another snowfall measurement, and I saw that I had an additional 2 inches of snow on my board. So I add that to the 2.4 I measured in the morning. Now I have a total of 4.4 inches for the storm, and it's still snowing outside. So once again, I wiped my snowboard completely clean, and I put it in a slightly different spot, and I go inside. And the following morning, the snow is ended, and I take my final snowfall measurement. I see I got an additional 1.2 inches of snow on that board. I add it to the total, and I see I've got a total of 5.6 inches. I wipe my snowboard clean, and I put it in a different spot in the snow, and I go inside to report it. So that's the way we would ask that you measure snowfall. As a winter storm is occurring in multiple measurements. Go ahead and take your measurement from your snowboard, wipe it clean, place it on top of the snow in a slightly different location. All right. There we go. All right. So we talked about snow and sleet. Again, they're measured. These are forms of frozen precipitation. They hit the ground already frozen. Now, freezing rain is different. It hit the ground as a liquid and then froze on contact with the ground, which is why it's nice and smooth. Now, we also like to know how much ice has accumulated in your area. And we know that this can be difficult because sometimes the ice is mixed in with some sleet and some snow, and it turns back to freezing rain. It can be sometimes a mess. So we ask you to do the best that you can. We know that it's going to be difficult, and it's perfectly fine. Now, for measuring freezing rain, ideally, what helps us the most is measuring it from a flat surface. So you can see the image on the bottom, the top of a flat little post there, or maybe from a picnic table, taking a piece of that, measuring the thickness with your ruler, and letting us know what that is. Now, sometimes it's just not possible, so the next closest thing that you have lying around is a round surface, like a tree branch or a railing or whatnot. Best way to measure that is to measure the thickest part of the ice and the thinnest part of the ice, and take a average of those two thicknesses and report that to us. All right. Either way, letting us know what you measured from, whether it was from a flat surface or from a radial surface, is very important for us to know, because there's a little bit of a conversion that goes into that. So please, when you send in your report of ice from freezing rain, let us know the thickness, and let us know from where that you measured that freezing rain from, that ice thickness from. All right. So now we get to the part where you let us know, now that you have your measurement, you let us know how much wintry precipitation you have in your area. And the way to do that is from our webpage there. If you scroll a little bit ways down, you'll see the chart of icons there. You'll see one that's called Submit a Storm Report. So go ahead and click on that icon. And from there, you'll have an option of the different types of weather that you can report. Now, if it's snowfall or sleet, you can choose the snowfall option. If it's ice from freezing rain, you can choose that option. So there's two separate options there. And unfortunately, you can't report both types in the same report. So you would have to make individual reports for each type. So once you've chosen the type of weather you've had in your area, a lot of it, the following information is pretty self-explanatory. You tell us the time that you took your latest weather observation at and a date. You tell us how much wintry precipitation has accumulated in your area. All right. You can select hopefully you select I measured the snowfall as opposed to estimates. Using a ruler or something to measure, that's the best. And then you have a remarks section there where you can fill that information with whatever you think that we need to know about what's going on in your area there. And feel free to spell it out for us. All right. There's no information that we'll think is too insignificant. Feel free to provide as much information as you can about the weather that's taking place. If you click the next button, from this little part, you select, let us know your location. You can either use your device's current location if that device is enabled to allow that. If not, just go ahead and provide your address of the location where you took that measurement. Once you click the next button below, you'll have an opportunity to review your report to find out what it is exactly you're sending us. And if you feel that you have to change something, you can just click the back button. But if you're happy with the report, go ahead and click Send Report. And that goes immediately into our office to let our forecasters know within about 30 seconds, we'll be reading a report and taking a look to see how this lines up with our weather forecasts and our watches, warnings, and advisories.
Hey, Nick, I have a question before we talk about CocoRAs. So as a warning coordination meteorologist, one of my responsibilities is to work up verification numbers. So in our forecast area, Dennis talked about to verify a winter storm warning for Roanoke East, it's 4 inches of snow. For the mountain areas, it's 5 inches. And ideally, I'd like to know when those values are reached. How does that work with regard to taking the observations in 6-hour intervals?
So the best way to do that is if you see that you've reached, so about 4 inches of snowfall accumulation east of the Blue Ridge, and if you're across the mountains, 5 inches of snowfall accumulation, you can take a measurement without clearing your snowboard. From that point on, you can tell us, hey, at this particular time, we see that we've reached 4 inches. We'll send another report in later on with our latest accumulation. But right now we're at 4 inches in the Piedmont, 5 inches across the mountains. And that lets us know that, hey, we've got winter storm conditions across our area. Excellent. So some of our viewers here may already be participants of the CocoRAs. And CocoRAs is a network of volunteer weather observers. And CocoRAs stands for Community Collaborative Rain, Hail, and Snow Network. And this is a nationwide network of volunteer weather observers. We have several already across our area. And this is a great opportunity for you to take a look at this and get an idea if this might be of interest to you, if you're a weather enthusiast. All right. So the gist of being a CocoRAs volunteer is once a day, usually in the morning, you go outside, you take a precipitation measurement from your rain gauge. And you can see here in the left, a lot of people here, they have rain gauges set up on posts in your yard, on mailboxes, someplace that's convenient for them to reach so that they can get to that location easily so they can see their weather observation. We've got a very simple, easy to use web form that you can use on your mobile device, on your home computer, that allows you to send in your report. From start to finish, taking a weather observation is usually 3 to 5 minutes tops. Only during extreme weather events may it take an extra few minutes. And the benefit of CoCoRaHS is that it provides us with a far better, more detailed look at how much precipitation has fallen across our area. So if you look in the bottom left image there, these are radar estimated rainfall amounts. And you can see it's very broad and it doesn't give a lot of detail as to how much precipitation has fallen, versus with the CoCoRaHS reports on the bottom right image there, you can get a more detailed idea from these ground truth reports that people provide in the morning. So it really helps us as meteorologists to make sure that we get our forecasts correct, and also to make us better forecasters so we can serve you better in the future. And here's a great example of a CoCoRaHS observer helping provide us with a detail that we otherwise wouldn't have known occurred. So in this portion of Texas, a very slow-moving, almost stationary thunderstorm occurred at sometime during May of 2008, and this one station received 7.12 inches of rainfall. And this was an actual amount. This wasn't just a mistake, mistakenly entered into the form. And you can see here on the radar image in the bottom right of the screen there, it is not an impressive looking storm. So someone who's looking at that would say that there's no way that there's 7.12 inches had it not been for the flash flooding that took place in the area. So it was a very real estimate. And that was provided by a CoCoRaHS observer. So you get an idea there. All of it fell in a 2-hour period. And that's a report, that's an observation that a remark that the CoCoRaHS observer provided. So that detail really helped the forecasters to understand what was occurring that day with that thunderstorm, given the flash flooding that took place. All right. So signing up for CoCoRaHS is extremely simple. If you go to the CoCoRaHS website, there's a link that allows you to sign up. You basically provide your information, which is your address, your name, your contact information. From there, it will provide you a link where you can order your own 4-inch plastic rain gauge. Now, the CoCoRaHS network does ask that you use a standardized 4-inch rain gauge, and you can see a picture of one of those on the left. And it's a high quality rain gauge. It'll last. I have one at my house I've been using for 10 years. It survived, it's weathered the elements, and it still looks in really good shape. It is standardized, so everyone's using the same piece of equipment. It measures to the nearest 100th of an inch, so it's a great investment. All right. Once on the website and you have your rain gauge, you can begin training by viewing some of the training slides. It's very simple to take a weather observation, but the training slides, the training videos will make it even easier for you to start taking your weather observations. They're very easy to follow, and they're entertaining, as a matter of fact, to watch. So once you've got that knowledge in place, you put your rain gauge out in your yard, and the training will help you choose a good location. Again, someplace that's out in the open, convenient for you to reach. Finally, you begin starting your weather observations. Usually it's a time that's convenient for you, preferably in the morning, but whatever works best for you. All right. So we do have.
Yeah, a couple of questions.
Yeah, a couple of questions. So one question that has been asked of us: if we transition from snow to sleet, freezing rain, or rain prior to hitting the 6-hour mark between knobs, do we want an intermediate reading at transition time? I would say just stick to the 6-hour rule as far as sending your observations. So even if we transition to rain in your area, don't worry about it. We still take just take your measurement at the 6 hours, and I would just wait till the back end of the storm to kind of break that 6-hour rule. So keeping it at 6 hours is the best.
And I just, to kind of elaborate on that, Nick, I typed in something that you can Google search. I think what would really be helpful in terms of like the transition of precipitation type is downloading the MPing app. And we have those observations right on our workstation. So you can say, hey, now it's freezing rain, and just type that into that app, and we'll see it on our workstation. So just Google what I just put in the chat room there, MPing, lowercase M-P-I-N-G. More questions rolling in, Nick?
Yes. So if we do this every day, should it be at the same time or after the event? So I'm guessing that we're talking about Kokoraz there. And if I'm not, go ahead and please correct me. But yes, take your yes. Okay. So you take your weather observation with Kokoraz every day at the same time. And that gives us a 24-hour to 24-hour measurement of precipitation that fell in your area.
Yeah, thanks, Lucinda.
Yeah.
And yeah, Diane, I'm so glad you mentioned that, because this is as Nick said, a really high quality gauge. It's worth a lot more, but through the Kokoraz program, you get it for about the same price as a new pair of shoes.
That's correct. So they're usually anywhere between $35 and $45. But again, when you factor the quality of the material that it's made with, it's going to last you a long time. It's a good investment as opposed to something that you pick up at maybe one of your big box stores, and within 2 years it's kind of falling apart, or it's cracked, or the UV from the sun has caused it to kind of disintegrate. Are readings from a Davis tipping bucket gauge acceptable? Unfortunately not. And here's why. Some of the Davis, the models of different weather stations, regardless if it's Davis or Tempest or whatever is out there, they change from model to model. So over a short period of time, the different models might produce different results. And the good thing about using this manual rain gauge, this clear plastic gauge here, is it's standardized all across the Kokoraz network. So we're kind of comparing apples to apples in that regard. So using something that's standardized is always better. That way we know that we're using a reliable piece of equipment. And that's, yes. Another question here is, do we report our weather observations even if no precipitation fell? Yes. Even if nothing fell, go ahead and go into the website there and report 0. And that makes sure that we know what happened, because it could be, hey, it could be that it didn't rain in that area or snow, or they just forgot to report. By entering the 0, we know for sure that you didn't see any precipitation fall in your area. And yes, we can use the gauge for snow. So you can see here the parts of the rain gauge. The top comes off and that inner funnel comes out. And that's actually preferable during the wintertime. And the reason for that is that outer casing is very sturdy. Water can fall into that. It might fall as rain initially and then and then freeze afterwards. This outer casing can withstand that freezing, whereas the inner tube and that funnel won't. You want to leave those indoors. But yes, this is an all-weather gauge, and it can be used during the wintertime to capture snow, ice, sleet, whatever falls from the sky. Great questions. I love it. All right. So we're getting close to the end now, and we've talked about wintry precipitation, but this is certainly not all of the hazards that we can face during the wintertime. I mean, we can have strong winds that produce dangerously low wind chills that Dennis was alluding to. Fog, the pea soup out there that can make travel extremely difficult. And we have all heard about the multi-car pileups that can sometimes occur in foggy areas. And certainly we're in the area where flooding can occur year round. It's not unheard of, even in January, to get warm spells after some heavy snow that causes rapid snow melt and flooding to take place. So we want these resources available for you so that you can research more on your own a little bit to find ways to stay safe during the wintertime, regardless of what Mother Nature throws at you. All right. And we thank you for your support. Here's our contact information from our office. As Phil loves to say, if it's weather you love, go to weather.gov, and our website is right there for all your latest forecast and weather watch warning needs. Our phone number here, 1-540-553-8900 to reach our office. If you've got pictures of what's going on in your area, pictures are worth 1,000 words, and we love pictures. So we encourage you, please. Here's our email address. This is an email that reaches out all the forecasters who are on duty at the time, working those winter weather events. And by you sending pictures into our office, even videos, if you can do that, letting us know what exactly you're seeing in your area, that gives us a really good idea as forecasters of what's going on. So we love when you receive that. And of course, we do have Facebook and Twitter X, formerly called Twitter, accounts. Feel free to post information there as well. And that often encourages other people to do the same, to send in their reports from their areas. So it's great when we see that happen. And with that, we've been already answering some of your questions, but feel free to pass along additional questions.